Gaan we beginnen?
Yep,
Okay, so welcome everyone. We are here for the graduation ceremony of the Master Nanotechnology, and we have 3 candidates today. It's nice if you look from outside this room because we cannot have that many people on campus now. But before I start myself, I will have a small video from the Dean of the Faculty saying welcome.
Good afternoon. I am delighted to welcome you all to this graduation ceremony of the University of Twente. To all parents, siblings, grandparents, friends, and colleagues, thank you for joining us today. My name is Jennifer Herrick, and I am the Dean of the Faculty of Science and Technology. I am joined by the faculty's Vice Dean for Education, Nick Benes. On behalf of the rest of the faculty board, we are very grateful to be here, to celebrate your success and bear witness to your formal graduation. In Dutch, it's called an academische plechtigheid, an academic duty. But really, it's a great pleasure and honor for us to be here. Nonetheless, it is a formal ceremony which calls for a certain level of decorum to mark the formality of this academic occasion. Hence, we are dressed for the part and would like to use this opportunity to impart a few words of wisdom. Dear graduates, in many ways, today is the end of a long journey, a journey of academic and personal development, of self-discovery and awareness through your courses, projects, and through many different extracurricular activities. Today marks a new beginning as you continue in your quest to finding your life's purposes. I said purposes on purpose, because many things await you, personally and professionally. Your education has taught you to be flexible, how to adapt, as the world around you is changing so rapidly, where the challenges of society require increasingly technical solutions. We encourage you to continue throughout your lifetime to find and to make the most of opportunities to learn. Today's milestone is certainly worth marking, worth celebrating. You are about to receive the distinction of an academic degree from the University of Twente. Carry it with pride. Congratulations to our new graduates. We are proud of what you have accomplished and grateful for the chance that we have had to teach you and to learn from you. We wish you success and happiness as you continue on your journey. Congratulations to the program management, to the teachers, tutors, supervisors for their role in your success. And congratulations to your families. Thank you for your support and encouragement of their education.
So, welcome also for me. I'm Herbert Romis, I'm the Program Director of Nanotechnology. And, well, this is my first graduation ceremony, so I'm as new as you guys to this. So, but we'll get there. It's going to be a great thing. First of all, nanotechnology is a very interesting program. Well, you witnessed this. It's a 2-year program, characterization, fabrication, design part, all these things combine and you pass this. And today is the day to look at that. So, with that, what we're going to do is very simple, but at least for Lida and Jeroen it will be very simple. You only have to watch what Jirka is going to do. So she's going to be the example how to do the ceremony. Right, Jirka? Okay, please come forward and stand over here. So, Jirka, long way from home, what you call home, I suppose. Mexico.
Yes.
Yeah? So, and you were here, Master Nanotechnology, and what you did is structural coloration of cellulose nanocrystals coated fabrics for sustainable value creation. That's a long title, a very nice sheet, and please explain us something about this.
All
What
right.
did you do?
Well, structural coloration is just a fancy way to say that color is produced by physical means rather than chemical means, like normal textiles and fabrics. The purpose of my thesis was to bring that sustainable side to textile materials, which you may know that they are quite, well, the industry is quite polluting. So yeah, I wanted to bring something to that side that's always important in technology. As you can see, that was the result, some shiny red, well, I don't know if it's, well, for me in this picture it's really clear, I don't know if it's clear in the projection, but you can see some red, green, yellow, very vibrant colors, and that is not produced due to pigments or dyes, but just because of light and interaction with matter. If there was something that will stick with me forever as a lesson that I learned from this thesis, is not really something like sciencey or really nerdy. It's just that nothing so vibrant and so beautiful like this builds in one day. It really takes a lot of time, and most important of all, it takes patience to achieve beautiful things like this.
Thank you. So, now we come to the next step. And the next step is that a few words will be spoken by your supervisor. And this is Julius Fangschel, who unfortunately is not over here, but we have him on a team possibility. So I have to switch on the team. He cannot see us, but we should be able to see him. A moment. So let's see if he answers the call. He promised he would be in. So let's see. Otherwise, I will have to say something. That's going to be a little bit more difficult. So this was the way we should make connection?
Yes.
Okay, then I will try it once again. One moment. Let's see if he's still over there. Yes, there he is.
Oh yes, I'm here.
We have to
Yes, I'm here.
move a little bit. Microfoon weer uit. Thuis wordt Let's see. Can we hear you now, Julius?
Can we hear you now? Is this better now?
Yeah. So,
Fantastic.
can you turn off your sound? Okay. Yep. Okay. Please start, Julius. No, sorry, you have to. You have to turn off your live stream. So, if you could turn off your live stream, it would be better.
Okay.
So, how are we going to do this?
Yeah, I think because he has the live stream on this side, or he has to turn off his computer sound, because that's where
Can you turn off your computer sound, any chance, Julius?
Any chance, Julius?
I can turn off my computer sound.
Yeah,
Like this.
yeah, great. So, we can hear you.
Of course, if I turn off my computer sound, then I do not hear.
he also can't see you.
I do not hear what you're saying.
Okay. You can simply
Yeah,
start.
better?
Yeah, okay. Yeah. That's a little bit difficult in communication, but
It's
yeah.
a little bit difficult in communication, but
Well, I think it's getting better now.
No. You simply turn off your live stream and then you start talking. Ik probeer geen die camera.
Nee,
Ja, oké.
no.
Ga je weg. Oh. Hoe gaan we dit aanpakken?
Yeah, he just needs to know that he needs to mute his sound.
If you can write in the chat,
Yeah, right.
Okay.
because I don't think he can hear you that well.
Okay, well, we have a little bit of time, so
Just tell him to deliver the message without.
He has to close his live stream and the YouTube video.
Yeah, I think it's, but I think it's just
sound.
yeah, he needs to just mute his sound on his computer, because I think that's where the feedback is coming from. I don't think it's the live stream, because the live stream stopped sending sound at some point.
So. Yep. Okay. You can start. Ah. Modern communication.
Yeah, it's starting good.
Okay.
But we can still hear ourselves through it, because if you say something then we hear it there.
I can still hear you.
Oh,
No, it's good.
yeah.
Good.
Okay, well, I can start. This is an interesting conversation because I see nothing except some nice smiling faces on my screen. So let me try to kind of talk in the dark a little bit, and then I get written messages and you can steer me. So you see, nanotechnology, one of the interesting things that makes now the world go around is...
Oh no.
nanoscale electronics and all the programming on the blogger close to my heart. I am in love with colors, and I am in love with nature. And she combined the two things in such a way that she started paving the way for a very interesting and very a conscientious exercise to actually combine textiles, nature, and colors in a nice, peaceful, and environmentally friendly way. And by doing so, she used the knowledge of photonic crystals that actually came from devices like the computers. We are now using devices like communicating with light. Jirka, when she first came, she expressed her desire to actually do a joint program with Saxion and University of Twente. And I was very much impressed by her dedication, by her firm, very well worked out, ready to go plans, and of course by her smile. She came in, and ever since I saw her for the first time, this big smile on her face and the curiosity in her mind have not disappeared. And as a result, it shouldn't take you by surprise that her work, her research, it has become a wonderful piece of work. Indeed, with 2 degrees, one here at the university and the other one at Saxion, simultaneously at the same time. It was a global exercise because if I remember correctly, the parents were watching from Mexico and we all were kind of very excited how this would go. Well, sometimes hiccups happen like today, but this is not what we should remember. What we should remember is a beautiful piece of work with beautiful colors, a smiling, great young scientist on her way to fulfill her dreams. And I hope that not just the scientific impact that she gained remains and will make a long-lasting impression, but also the pleasurable moments that she spent around liaising with her student colleagues, and at the end of the day also socializing within the group. Jirka, we will wish you all the best for your future career. And what I usually say at the end of such a short speech is, use your knowledge wisely. I congratulate you, your family, your loved ones, and everyone whom you think deserves on this degree that you acquired, in fact, a double degree. And of course, I want to thank the educational program as well as the links with Saxion, which made this journey so memorable. All the best, Jirka. Thank you.
So I now switch off his sound. So now I can go back to the link and hear us again. So let me also switch on the PowerPoint once again. Because this was your work, that's why we are here. So, Jirka, now you're almost a Master of Science, but there's one important thing still left to do.
Okay.
And that's namely, sit over there. Please sit over here. Now, what you have to do is take a moment time, read through the document and look if your name is spelled correctly, whether your date of birth is correct, all those kind of things. And if that is true, then you have to take one of the pens lying over there and you have to place your signature on the left side.
Okay, big moment.
At the moment you have finished your signature, you graduated.
Okay,
It's as simple as that.
perfect.
Okay, now great. Now what you have to do is hold up your diploma for the camera so that also people at home, if they are watching, can see this is your diploma. Congratulations.
Need to find a zoom ring.
Okay, that's it. Now we come to the last stage of the graduation ceremony. And the last stage is that you walk over to the table that we have standing over there. And when you're at the table, you have to pick up 3 things. Well, there are actually 3 different items. So from each item, you have to take one of these items. So, congratulations.
Thank you. Like virtual.
No, yeah, like this, yes.
Toby.
Exactly. And shall I help you with a hand, because you always have the ability to put a lot of things in your hand, so that you really have to make a very large trajectory. Okay, so Lida, you are the next one. Please come forward. So, Lida.
Hello, everyone.
Nice to that you are here.
Yes.
So, you came from Greece. So
Exactly.
you are here now for how many time? How long?
2 years
Yeah.
and 3 months.
Okay. So, Master Nanotechnology at the University of Twente.
Yes.
And although I know that you were in the course I give, very important of course last year, but
Yes.
that's it. But you also did your
Third quartile.
Yes, exactly. But you also did your master thesis, and you did your master thesis on fabrication and characterization of curved mist tunnel junctions for terahertz rectification.
Is it a bit
It's a long title.
I know. I try to explain.
Yes, but there are fields in which you have even longer titles, so please go ahead. What did you do?
I have an extra slide
Yes?
here for you. So what I actually did is what is my motivation? My motivation is inspired from renewable energy sources that we have nowadays, and especially the solar renewable energy sources that we have. And we know that we can exploit the solar energy by using photovoltaic solar cells. But the problem is that they have a limited efficiency, which is approximately to 33%. So what we propose is to create a new type of device, which is called rectangular solar cell, that can increase this efficiency to even 90%. So what exactly, I will just briefly explain to you, what exactly is a rectangular solar cell. It consists from an antenna, as you can see here, and a diode that rectifies. I tried to fabricate the diode, as you can see here from the schematic. So radiation from the sun is absorbed from the antenna, and an alternate current is produced, and through this diode is rectified, and what we actually get at the end is a direct current, so we basically have electricity. It is important and very tricky for this type of diodes to rectify and be able to rectify frequencies in the range of terahertz. And they should have very specific characteristics, for example, a low RC time, conductance and symmetry, and non-linearity. Until now, the junctions that they most of the times use are planar mean junctions. This is the type of junctions that in the literature you can basically find. And what we actually did was to go to the curved mist tunnel junction diodes, and the reason is because we're able to combine all these three very important characteristics. So this is the envisioned device, how we thought that the device will look like. And these are beautiful images that we took from the transmission electron microscopy. So we actually verified what we had in our head. But when we came to the measurements, because we had to characterize the device, it was very nice because we had from the IV measurements that we did. It was nice because we had this conductance and symmetry, which means that we have diodes that can rectify. But we were not able to work to these high frequencies because we had, of course, a low capacitance that is required, but we had a very high resistance. So yeah, the time was, this RC time was very high, which means that the rectification ability and this terahertz regime was not reached at the end. But it was a very nice work and a very nice experience, and really clean room work, characterization, fabrication. Perfect.
So when I listened to you and also the
I
way
really
you move, you liked it.
A lot.
Okay, great.
So thank you.
Okay, but now it's time for asking Niels Stas over here, your supervisor.
Yes.
So, and what he thinks about you.
Yes. Be nice.
So, Niels.
Yeah. Hello everyone. So it's an honor to say something here on this graduation of LIDA, and it's quite a story I have to tell. So LIDA, she joined the MCS, let's say, community around I think the summer of 2019.
Yes.
And she started with an internship actually at SmartTip company, guided by Edin Sadowitz. And it was in collaboration with the MCS group already. And then she worked on the formation of metal nanofilaments for functional tips, SmartTip, but also way beyond potential applications. And then when she indicated her interest for the master assignment at MCS, we quickly found out that Lida was much interested in the nanolab. And to see what can be made there, to be learned there. So we tried to find an assignment where there was a lot of hands-on activity in the nanolab possible. And that was what she explained on the curved tunnel junctions, and it was actually the daily supervision of Jasper Corneli, one of our PhD candidates. Now it all went well in the beginning. I think in October, November, Lida got the clean room training, and you quickly designed the devices, the masks, and started with the clean room work. And then it was February, March, and we all know what happened. And suddenly everything had to be stopped and a rather difficult and uncertain period actually started. But actually one of the few labs that stayed open here at the UT, that was the Nano Lab, but mainly for the commercial activities initially. And then it was gradually and carefully started up again, also to allow other researchers to enter again, but it was limited capacity. And it was, I think, a big disappointment for Lina to find out that for master students it would be difficult to re-enter. So we decided that our cleanroom engineer Erwin Berenschot should take over the fabrication. That was step one, but then we were still in trouble because all the other labs were still closed for master students. And Lina could only then catch up a little bit with writing, and you went to Greece, I remember, for a while. And yeah, that was also a moment that you started signaling that it was that you felt uncomfortable with the situation. And so we started to further develop the plan and signal to the program that we wanted the master students to enter the labs again. And finally, luckily, that was possible at a certain moment, but it took a few months. Now then I finally could readjust the plan and the planning, and Lina got the samples from Erwin to characterize. But actually that's quite tricky if you don't make them yourself. Every little detail matters, and then you have to find out what has been done and what has become of it. So we were also very happy that the first measurements, the static measurements, worked out well. And then we had a major part, which was the measurement of the capacitance of the junctions, as you explained, for the RC time constant. And that was actually really interesting, because it turned out to be much more difficult than we thought initially. And Lina took the challenge. During the summertime, when a lot of us were enjoying the holidays, she was studying all the manuals, and she actually did a great job to put together the setup and the procedure, and it only took a minor tweaking to get it to work. And you were able to measure the absolute capacitance in the picofarad range. Yeah, what was actually interesting about this period is that we noticed that Lina actually performed best when we as supervisors didn't interfere too much. And that is actually, to mention first, that means that you showed a lot of character and quality in this period. And it also showed that you improved a lot, you made major steps in your development as an independent researcher, so it was very nice to see. But also it was something to think about as a supervisor. Yeah, so basically in the current period era where there's a lot of orientation on the result, there's a lot of focus on giving a lot of guidance to the students. And although sometimes more is better, often less is also better, as we found out. So we should trust and give space to our students and co-workers in general, and give them space to explore and also to make mistakes. And to find the right balance is, for supervisors in general, I think is a continuous challenge. Now regarding the Nano Lab, so in the end, Lina recently found a job with a new spin-off company called Untitled, which she started in October. And actually now she can spend a lot of time in the Nano Lab. That's very nice. To conclude, Lina, and then also I speak on behalf of Jasser and Erwin, and Edin, and Björn, and Han. I would like to say that the past 1.5 years have been an interesting journey, and we're very happy to be part of that. It's really nice to have you around in the group, with your motivation, with your eagerness to learn, with your positive attitude and your good sense of humor. What we have seen also, that is when you see a path forward, with your motivation you can achieve a lot. So please keep looking for the path and trust on your qualities. So many thanks for all that you contributed with your good work, and our congratulations for obtaining the master's degree today. All the best for the future.
Thank you. Thank you very much.
So, we're almost there, because now she has to do the job of signing. Lina, please sit down and take some time for this. So, first study whether your name is correct and whether we have the right date of birth. And I should mention that you only get this diploma once. So be very careful with it. We don't have spares. Yeah? Satisfied? It's yours?
Yes, it's mine.
Please take a pen and put your best signature over there.
It doesn't write.
At least it did not do anything, that's good. So. Great. So, you want to hold it up for anybody who's at home watching? Ah,
I did it.
great. So, which one was the one that didn't work?
I think this one.
Okay, I'll take this one back. Okay, so now there's the big task of carrying things. So that's always nice, certainly in these times, because you can say, well, you have to do it yourself. Congratulations, also from the program. Yeah, indeed.
Thank you.
So. So, the next candidate is already in view. That's Jeroen. Please, Jeroen, come forward. In fact, we get very different things to hear today. So, you already are the last candidate. 3 candidates, welcome. Jeroen, you worked on TMBS, I think it's pronounced TMBS, nanopillar diode. Now there's a subtitle, but I'm sure you're going to talk about this, right?
Indeed.
Go ahead.
Oh yes, I did my master project in the Integrated Devices and Systems group under the supervision of Bernard van der Wel as my daily supervisor. And actually I continued on the work he did for his master project, which is improved design and simulations of a TMBS nanopillar diode. As you might know, a diode is an electrical component that ideally blocks the voltage blocks the current in one direction and lets the current pass in the other direction. However, these diodes have a fundamental trade-off between the specific on resistance and the breakdown voltage of a device. The specific on resistance is a figure of merit for both the resistance and the footprint on the wafer for the device, and the breakdown voltage is the voltage which the diode in reverse bias starts conducting again, so breaks down. Then I also have a graph over there, which shows this limit for simple devices, which is shown in the blue line there. So everything that is basically below the blue line is in general for simple diodes not achievable. However, when we make use of the nanopillar diodes, which are shown in the background as part of the fabrication process, there we can tune the electric field inside the pillar so that it can withstand higher voltages. And when we do that, also out of simulations, it was shown that these diodes are indeed capable of breaking this limit. Because the simulations I did are shown as the 3 little circles on the graph, and as you can see they are below the blue line, which is usually the limit. And then you might wonder, what can this technique actually be used for? Well, in diodes, the diodes can be made smaller while keeping the same characteristics, which saves resources of the diode. But also the other way around, we can make a diode with the same size that suffers of less power losses. And these diodes are used in more applications than you might think of, because, for example, in phone chargers, you also find these diodes. So even with a marginal gain per diode, it can still have a large effect on the big scale. And yes, that
Large effect on the big scale. For whom?
Well, basically, if you choose to go for the path with the low power losses, then it saves energy.
Exactly. So, yeah, so it's attractive. So, now it's time for Bernard to come forward and to give his address to you. So, Bernard, you're an alumni of Nanotechnology?
Yes.
So, this is a very nice thing that you are now actually in the other position.
Yeah.
So, to address it. Go ahead.
Yeah. Well, Dieu, it's very nice to see you here. So on the 4th of October last year, you appeared in my office. You were looking for a final assignment, and a colleague, a PhD of mine, went through the offices with you to see what assignments we have to offer you. We worked with 3 PhDs in the end in our office, and we all had ideas for an assignment. And soon we found ourselves in the middle of our measurement lab discussing all the possibilities. I had an assignment which for a large part would consist of fabrication, and for a smaller part would consist of simulations and measurements. And at the time I got the impression you were not simply interested in theory, but would appreciate some practical work as well. So in my eyes you were a very good match to for my assignment, but of course you still had to make a decision which of the 3 assignments you would choose. So on the 10th of November, you notified me of your decision. The assignment that resonated most with you was my assignment. So this made me very enthusiastic, because now I could, in parallel with my PhD research, which is on another topic, continue my research that I started during my master's. During my assignment, I designed and fabricated a diode, which, as you showed, exists of millions of nanopillars with a diameter 1,000 times smaller than the thickness of a human hair. So, very small sizes. During my measurements, however, we found out that some problems arose with the design and fabrication process. So that's where you come in. Your assignment was to improve the design by means of simulations, and of course fabricate them in a clean room. Although you were missing some prior knowledge, you quickly accustomed yourself and could bring in your own ideas about how we could improve the design. But then, you hardly started fabrication in a clean room, and there came the pandemic. From one day to the next, students were no longer allowed into the clean room, and we were facing a dilemma. Wait for this to pass, or adapt the assignment. So, I'm very happy that we chose for the latter, because the coronavirus is still a strong force at this very moment. However, the very thing I think you selected the assignment for, which is the practical work in the clean room, had to be taken out of the assignment, which was very unfortunate. But we decided that you would study more effects by means of simulations. And we know, and you know, this wasn't always easy. The software has its quirks, and it's not very user-friendly. But your simulations have given important insights, such as where is the diode leaking, and what is the dominating mechanism. At the end, you've conducted thorough research, and have written down and presented it clearly. Seeing your results, I'm proud and happy that I was allowed to be your daily supervisor. At the present moment, I can now even call you my colleague, as you've started your own PhD within our group, which is, as I understand correctly, going to be about simulation of the effects of integrating piezoelectric material into high electromobility transistors, if I'm correct. Not really. I tried to verify, but I couldn't find a way. So, well, then you can tell me all about it later. But by now, you and the simulation software go along well. So I'm very sure that everything is going to be all right. So Jeroen, once again, I may congratulate you with obtaining the title Master of Science in Nanotechnology, and I wish you all the best with your PhD.
Thanks.
Congratulations.
So, thanks. So, now we come to the final thing to do.
Yes, the most difficult of all 2 years.
Please sit down, Jeroen. Have a look at the text.
Yes.
Check your date of birth.
All correct.
Now,
And oh, that's fine.
yep.
Yes.
Excellent. Congratulations, Jeroen.
Okay, just wait for it to focus.
Ah.
Yeah.
Nice. Okay.
Okay.
So, now for you, the task to clean the table.
Yes.
So, we're getting to the end of this ceremony. I have one last word from the Dean in a moment and the Vice Dean. But before I turn to them, I first of all, of course, want to congratulate all three of you. And although I've seen three very different projects, I have seen two things in common between you. First of all, you're all Masters of Science and Nanotechnology. That's an obvious one. And the second one, you all have big smiles. So, congratulations. And now let's hear what the Dean and the Vice Dean has to say about this. Oh, one moment, I have to start again because I muted him. It's not a very nice for me, but that was to make sure.
It's still there. The
So, there we are.
We have almost reached the end of this formal ceremony. But before this, I would like to personally also congratulate you with this great achievement and this milestone in your life. I'm sure many of you would like to stay with us at this university, and some will actually do this, becoming, for instance, a PhD, ultimately a professor, working on science and educating future generations of students. Others will depart and they will pursue a different career. I hope all of you will remain ambassadors for our university and will remain connected to this university and will feel welcome at different moments in life, visiting us and sharing the experiences that you had throughout your career. With this, I would like to formally close this ceremony.
So, if you have been watching, not from in this room, nice to have you with us, and we're now going to put on the last slide that we have, and let's see if that works. Yep.